Hi, everyone. Thank you very much for joining us today for today's webinar, Accelerating Cloud Adoption Securely in the Public Sector. We appreciate you taking the time to join us today. My name is James Campbell. I'm the manager for public sector at HashiCorp in Australia. I'll be the MC today. Before we get started, I'd like to give a couple of quick housekeeping and agenda items. First of all, today's session is being recorded. And we'll make a copy of that available on our website soon. We'll send an email out to everyone on this call within the next day or so with a link to the recording. Today's webinar will run for about an hour and 15 minutes, and we've allocated 15 minutes at the end to go through Q&A and open Q&A. There's also a Q&A tab within the On24 platform that you can use during the presentation, and we will try and answer those as we run, or we may leave some of those questions to the end. We've got a great program lined up for you today. We've got HashiCorp's Regional Vice President, David Carlis, kicking us off. And then we've got our Global Field CTO, Brent Holden, who's going to walk us through secure cloud automation in the most challenging regulatory environments. And then finally, we've got a speaker from CSIRO, Brendan Speet, who's the manager of the CloudRight program. And he's going to share some insights and experience on how CSIRO are adopting cloud services safely and in a highly regulated environment. So as mentioned, we've got 15 minutes at the end for Q&A, so make sure you stay on for that. And with that, let's go ahead and over to you, Dave.
Cool. Thanks, James, and welcome everybody. Thank you so much for joining us this morning. I hope everybody's well. I've actually met quite a number of you. Those I have met, nice to see you again. Those that I haven't met, I look forward to meeting you as soon as we get through this, the current situation. So I'm going to briefly talk today about how to enable and what we're seeing in the market around enabling the cloud operating model. First of all, for those not familiar with HashiCorp, just a very brief overview. We were founded about 7 years ago, predominantly as an open source organization with 6 open source projects. And most people actually know us by our projects rather than the HashiCorp name. We have Packer, Vagrant, Terraform, Vault, Nomad, and Consul. Over the last 3 to 4 years, we've seen a tremendous growth in the enterprise usage of these products. 8 out of the top Fortune 10 companies have standardized on our products, and over 250 of the Global 2000. And we're seeing that organizations are not just moving to one cloud. They may have a single main cloud or 2 main clouds, say AWS and GCP, but they'll also be using Azure. Some parts of their business will be using Azure. They'll probably also be using some Oracle Cloud, potentially some IBM Cloud, and depending on where you are in the region, using Ali or Tencent, etc. So what we're seeing is really this multi-cloud. And this transition to multi-cloud creates some changes in both from a technology and from a process perspective. The concept of the move from static data center to more dynamic infrastructure is something that I'll cover on the next slide. But what we're seeing is this move from dedicated into, not just 1, but 2 or 3 public clouds. And these are predominantly where the applications are now sitting in terms of your systems of engagement. This creates some networking issues because the systems of record, be it because they're large Oracle databases or even mainframe applications in some of the financial institutions, are still pretty much within the firewalls, within the dedicated infrastructure. So we have connectivity issues there. We're also seeing a process change from ITIL, ITSM, where everything is a ticket-driven service. I need a new VM, I log a ticket. I need to change a firewall rule, I log a ticket. Into this world where we're really moving to sort of Uber automation. Everything is driven by an API and it's self-service. If you're running a CI/CD pipeline, you cannot wait to log a ticket and then get somebody to act on that ticket to issue a certificate, for example. So we're moving from this sort of ticket-driven service to, as I said, an API-driven self-service. let's just talk about this move from static to dynamic, because this is where some of the implications of this move to the cloud model are what we're addressing here at HashiCorp. Within your traditional data center, everything sort of had an identity. It was tangible. You had servers, you had physical firewalls, physical load balancers. Everything had an IP address, and you could route to that IP address. So it was very static. Amazon sort of changed all that, because we moved from these fixed assets to really deploying into a pool of services. You can deploy a VMware or a load balancer into this pool of services. And each one of these services that you deploy sort of has its own identity or its own characteristics. It has an API that we can use to communicate with it. It has some form of identity or identity policies, which states who can and who cannot talk to it. And it has a capability. The difference here, though, is that these services are designed to be mobile, so they can move. And that's what really is the major difference from this fixed asset to this mobile sort of services that have these characteristics. And that's sort of what breaks the traditional way of managing infrastructure and creates these whole new implications. At the operational provisioning layer, as I've mentioned, we're moving from dedicated to sort of capacity on demand, a pool of resources that, mixed VMs, containers, serverless, edge devices, etc. It gets really interesting at the security layer, where everything within a data center or even a private cloud was sort of firewalled. You controlled ingress and egress with firewall rules. It was all IP-based, and there was a clear network perimeter. As we move into public cloud and multiple clouds, we're really moving to a low trust, or in fact a zero trust. There is no clear perimeter, and we do not own the network. And so that security is moving from IP-based to identity-based. In other words, you need to prove who you are before I will share or connect with you. And that's one of the challenges that we're looking to address. At the networking layer, very similar. We're moving from static IP to service-based dynamic connectivity. And I'm sure you're all familiar with the concept of service meshing, either HashiCorp Console or Google Istio, where it's really service-to-service communication, utilizing identity as the trust rather than a static IP. The runtime is probably the most heterogeneous, where rather than just provisioning applications onto dedicated infrastructure, we're scheduling them across a fleet. And products such as Kubernetes, particularly for containers, or HashiCorp Nomad, which can schedule not just containers, but C++ applications across this fleet, are becoming used at scale across many large organizations. So when we start to break that down, it starts to get very complicated, particularly as you move to more than one public cloud, because at each layer, every cloud does things a little bit differently. At the provisioning layer, we have CloudFormation or ARM or Google Deployment Manager. We also have a lot of VMware and vCenter within private clouds and dedicated infrastructure. At the security layer, most of the public providers have moved to identity-based. You have IAM or Azure AD or GCP IAM. At the next layer, that we've seen Google Istio, Microsoft Azure has standardized on HashiCorp Console. AWS has App Mesh. And within the private cloud environment, we're seeing a mixture of NSX from VMware and HashiCorp Console. And as I said, at the runtime, it's still very heterogeneous. So this is a lot to consume for an organization. It's a lot of talent. It's a lot of skills that are needed. So really what we're aiming to do and why our tools are being used by so many organizations is we create a single orchestration layer. So using Terraform, using a single language, we can provision across anything, VMware, CloudFormation, Resource Manager, Deployment Manager, Oracle Cloud, IBM Cloud, utilizing a single language. Using Vault, we broker identity across all platforms, on-prem and in cloud, and utilizing Consul. Consul is the most widely used service discovery tool, but we can also use it to create service-to-service connectivity across multiple environments and multiple clouds. And then, as I said, Nomad at the runtime layer is being used for those organizations that are really scheduling applications at scale across multiple environments. I guess the reason that we're seeing this move and we're living this move right now, it's the end game is how do we get an application, a new customer-facing application, how do we get this into production as quickly as possible? And how do we industrialize this application delivery process? So if we look at the DevOps ecosystem that we're sort of seeing come to fruition over the last sort of 3 to 5 years, we have a version control environment, we have some form of library scanning, some security scanning, we have repositories, and we have multiple CI/CD systems in use. And within your organizations, you may have a single tool chain or different departments within your organization may be using multiple tool sets. But pretty much the ecosystem is still the same. We're seeing the same products being used across all organizations to get that development application into an operational perspective. And the challenges at the operational layer are, and we're seeing it's all infrastructure as code. So everything is being codified now. So your provisioning is all codified, predominantly utilizing Terraform, or if you're cloud native, use straight to CloudFormation or ARM, implementing identity-based security model, and implementing some form of service networking and runtime scheduling across the organization. And I would think that within most of your organizations, that's what you're seeing. So we're sort of getting to this point where a new multi-cloud stack has emerged. You look at from an infrastructure layer, traditional infrastructure vendors, HP, Dell, IBM, etc. At the security layer, we have Palo Alto, Checkpoint, networking, Cisco, F5, Juniper, etc. And then application servers, you have IBM, Windows, messaging platforms, TIBCO, and then databases, Oracle, MySQL, etc. These are being replaced by this new stack. So you're looking at Snowflake, who were just in the news last week with an IPO, Databricks, MongoDB with the MongoDB Atlas product, messaging layer, we're getting Confluent. Obviously, at the runtime, we have Kubernetes is the major player there. We have HashiCorp Nomad. Then in this infrastructure platform layer, we really have Terraform, which is probably provisioning 30% plus of all public cloud workloads currently. We have a tremendous amount of people using Terraform. In fact, I think there were over, in 2019, we had over 90 million downloads of the HashiCorp products. Interestingly, this year, it's a lot more. The coronavirus pandemic and people working at home, not having access to data centers, and also businesses scrambling to create more digital online platforms so that they can communicate and transact with their customers, has seen a sharp rise, not only in Terraform, but also in Vault and Consul. So Vault at the security layer has really become an industry standard for identity-based secrets management. It's a multi-faceted product that does, secrets management, PKI, provides encryption as a service, provides KMIP type functionality for advanced data protection. And we're seeing that most major financial organizations and most public sector organizations that are moving to the cloud and putting out workloads in the cloud applications in the cloud using Vault as their centralized management platform for secrets management. As I mentioned, Consul is a sort of multi-headed beast. It has a multitude of use cases. First one being service discovery. So, traditionally, as I mentioned, as we deploy applications, we provide an IP address and we can route to that IP address. Once we start moving to the public cloud and deploying containers, for example, hundreds or thousands of containers, these containers move around. We can no longer connect via IP address because we simply don't know the IP address. So Consul provides a service discovery functionality. You implement a Consul server and we start pinging the environment, and Consul can provide the routing information. At the first layer, it will provide that routing information for you to route to the service in traditional ways. Once you get more complex into service-to-service communication, it will actually provide the connection via the service mesh functionality or Consul Connect. So I hope this stack sort of rings true for your organization. Be interested as we sort of have more discussions with you for your feedback and input into what we're seeing across the planet. So really, what the HashiCorp message or thesis is to implement a common operating model to accelerate this application delivery. And our theory is if you have Terraform at a provisioning layer, you have Sentinel policy as code, you have audit capabilities, you have all the enterprise features, and you have Terraform modules that can be created and then published to people to use. So as long as people within your organization, you may have thousands or hundreds or tens of developers, but as long as they're using Terraform to provision, then they're good to go. You can provision 1,000 times a day and you know that you're within policy of your organization. Similarly, if every workload that you're putting into public cloud is utilizing Vault, then you're good to go. You can provision, again, thousands of times a day because you know that your secrets are trusted within the Vault environment. And as you're provisioning these multiple workloads and multiple services, if you're using Consul, then you know where they are, you can connect to them, you know the health of them, and also you can start moving into more advanced functionality like service meshing. And then Nomad just provides you that runtime scheduling across scheduling services into a fleet of infrastructure. So really, just in summary, multi-cloud is the platform for new applications. It's inevitable. We're seeing it in every market that we operate in. Here in Asia Pacific, Japan, we're experiencing huge growth in Australia, Singapore. We have customers across Vietnam, Indonesia, Philippines, Thailand. We have a large presence in South Korea. Large presence in Japan, and we're starting to sort of break out into Taiwan, into Hong Kong. We already have customers in China, and all of these customers are moving, if not at least to one, but to a multiple public cloud platforms. So this cloud requires a different approach. It requires a different approach to operations, security, and networking. The challenges are well understood. And it's really about putting in that single operating model to address these challenges and to enable your organization to take advantage of what cloud can offer. And then finally, industrializing the application delivery process is really the key. So formalizing those tool chains and getting them cemented within your organization. And we believe our products present a common logical infrastructure to enable all of the 3 points above. And really, at the end of the day, it's all about getting those applications into production and reaching your customers as quickly as possible. That's my lot for today. I hope you found that useful, and I will now hand over to our field CTO, Brent.
Thank you so much, David. I really appreciate that. Thank you for the informative presentation. It's always nice to hear you speak. So let's talk through my section, which is applying the cloud operating model. Although in this case, how it gets applied to public sector is via secure authority to operate. So we're going to talk through what that means, what kind of value that our public sector's customers have gotten out of it, as well as just how do these things work, and give you kind of a basic overview of each of the technologies, sort of going a layer deeper than David was just able to. So let's sort of look at, well, okay, so if you want to throw your digital tomatoes at me, I'm okay with that. I'm at Brent Holden on Twitter. You can also find me on LinkedIn as well. Now, David already talked through some of the obvious changes that are going on in the market. You have this traditional data center, and it's this four-walled place you drive to. Now, I think the less obvious things that are going in the market, David kind of alluded to, which are that the world is shifting away from everything being ticket-driven, and having ITIL as our standard process model. And when you talk to customers, or when I do, the way they describe it may be a little different. Some customers may call it CI/CD. Some customers may call it DevOps. I think it all falls under that umbrella of API-driven self-service. I think that is the way that they see really taking advantage of the agility that public cloud offers, and making it so that they're just able to move that much faster. And really, I think the phrase that David mentioned, the industrialization of application deployment, that's really what they're after. So if we kind of look, just briefly at what that looks like, even this sort of idealized kind of process, for most people, as for most developers, when they're requesting infrastructure to deploy an application, they have to go through these various technology teams that, this is how we always set them up. It was, you have the VMware team, they manage the compute farm. The Cisco or your Palo Alto team, they manage the firewalls, and maybe the F5 team manages the load balancers. And for developers who want to deploy an application, their first step is to file a ticket. And that first ticket is usually against the compute team. The compute team says, absolutely, we'll get it right up for you. We'll see you in about 2 weeks. And so 2 weeks later, you have your compute resource, and you're able to apply for firewall rules, and you say, okay, firewall team, I need certain ports open. The firewall team says, we will get right on that. We will review it as soon as possible. We will see you in about 3 months. And so 12 weeks later, you have your firewall rules open, and then you go to the load balancer team and you say, well, I'd like my app to have a load balancer in front of it. Could you please send me a load balancer resource? And they say, absolutely. We'll see you in about 8 weeks. So even in this super simplistic model, we're already talking 22 weeks just to get an app off the ground. For some customers, they may have automated portions of this. So you may have automated your compute portion where it only takes you 5 minutes to build a virtual machine. And even still, it may take you 5 minutes for that one portion, but it still takes you 20 weeks for the other portion. So your whole process takes you 20 weeks and 5 minutes. And that's really the time to value that we're looking to decrease. It's that overall expenditure of effort. And that really, a focus on that time to value, that's where HashiCorp sort of maintains a lot of its work effort, which is around the workflow. And what does it look like for people to do their best work in this API-driven self-service environment? How do we make people the most effective by making one API call that just does everything? They interact with all the different teams they need to, and they just deliver my resource as I expect. So that's really sort of the key ingredient for HashiCorp, because what we found is that some customers, even if you don't think you have a problem, this is, even though it's a US telco, I recognize I'm speaking to an Australian audience, even if you don't think you have an issue, like this major US telco, you definitely heard of them. We sat down with them, it was about a year ago now, and we took a look at what was that process. And it was 72 steps, took almost a year for them to deploy an app. And what they realized is that no one, you don't wake up in the morning thinking you're going to design a 72-step process. It's just not the way you think about the problem. But, now it's just because of the way we always did things, we'd assign a technology group. We put a ticketing queue in front of them and said, okay, if you want their resources, you got to talk to them via this ticket queue. And because of the sort of impetus that the market is putting on everybody now it's time to relook at how do we actually do work. And this has never been more true for public sector. This is exactly the kind of value that public sector is looking to drive. Because if you look at, there was a gentleman from US DoD who spoke at HashiCorp last year in the US. His name is Tyler Haley, I should say. He spoke directly about this shift. Now, this shift was away from the ClickOps processes, where you have the ticket queue sitting between your operations team and your developer teams. And then behind that was sort of the operations team, like this manual click effort, moving towards an API front end. This was the entire story right here. Now, he talks about it through all 4 technologies, and this is, even though it's sort of specific to Terraform, it does apply sort of evenly to each of our technologies. That was the whole point of it, was to get to this sort of this new state where you didn't have developers filing tickets for everything. Tickets are now the exception, not the rule, per the Department of Defense. So this is the new way they do things. This is the way their DevOps group does things, and this is the way they're going to start migrating apps to public cloud. So let's take a look at Terraform specifically. What does it do? Sort of how does it go about its business, and then sort of what problems it solves. So first is, what is Terraform? I think simply put, it's a way to provision infrastructure. Now the way that Terraform works is Terraform Core, this is sort of in the middle here. Terraform Core, what it does is it reconciles resources. So you declare them, and then it will determine, if I need a compute instance, does it depend on a network being available, for instance? So it sort of defines those relationships between different resources. But aside from that, it's really not particularly useful in and of itself. You really need what are called Terraform providers. Those are the things where if you're looking at implementing your API-driven workflows, what that sort of means is that behind the scenes, you're almost guaranteed to be supporting a heterogeneous environment. And so you have to have support for all these different things that you might encounter in your infrastructure, whether that's different networking providers, that might be different SaaS providers. In this case, there's Datadog or NS1, for instance, or GitHub, as you could sort of see AutoCAD in there as well. And that married to a cloud provider like Google or AWS or Azure means that you can provision things that have relationships with each other. So I have this compute instance that needs to live in AWS, but I can also provision the other SaaS resources along with that, even a Kubernetes environment or an app onto Kubernetes alongside that. So Terraform is an extremely powerful tool for creating these applications, and it really depends on those different provider plugins. The provider plugins, if you want to think about it like Windows drivers, it's another good way to think about it as well. It says here there's 200 plus more. That was as of last year. It was currently about 350. About 200 of those are fully supported. The other 150 are community. Let's sort of talk through what this means as far as being able to access your users. The users themselves, they have different interfaces to Terraform Core. So that could be them writing infrastructure as code. That could be them going to a ServiceNow catalog and selecting the catalog item that says, give me the Java app on top of AWS. And so there's different ways you can sort of give them access to self-service depending on their skill. The reason for that is because, just making it easy for developers to have one skill set to access different clouds is really how we define workflow. And so the idea that you're going to be multi-cloud, we believe that through and through. And so having one common skill set that, even though the code might be a little different, because each cloud is sort of developing its own unique aspects, you're going to have a common skill set and a common approach to it. What that means also is that you have a common approach to compliance as well. And I think one of the key benefits of a tool like Terraform is something like what we call our policy as code engine, which is Sentinel. I'll tell a brief sort of anecdote around Sentinel, and then we'll kind of move on. our Sentinel technology was co-developed by one of our customers, which is Barclays. We noticed that they had that goal of, we want to take that 22-week mission, bring it down to 5 minutes, right? So we helped them do that. And then what we noticed is that they called us a few months later and said, well, our deploy times are back up to 22 weeks. We said, well, Terraform didn't get slower. What happened? And what had happened was that Barclays had put a global risk and compliance officer in front of every single, we call it a pull request. So it's basically every single deploy that went through Terraform. And they had to review it and just review it against this Word document that defined their policy. There was only a few people, just a handful of people at the bank who were capable of doing that, and that's what caused the time to go back up. And so what we did was we created this policy as code engine to replace the human, so that way you could define policy in a way that was machine readable and something that you could trace and audit as well that would apply automatically to your automation. So Terraform can do things like, I think when most people think of policy, they think of, are you preventing certain resource types from being deployed? Which is true. We can prevent certain, like if you want to prevent developers from deploying like quadruple extra large instances in AWS, we can help you do that. I think another part of it is too, just maintaining that certain resources have to live in certain areas of your infrastructure. So forcing certain infrastructure types to live in certain regions, maybe one that's very valuable to you. Another may be a monetary policy as well. So giving a developer group a certain dollar amount that they can sort of play with and say, well, you have $10,000 a month. Here's what you can use to develop with. And then they're self-managing around what that dollar amount is. So policy sort of applies in different ways here. Let's click up a level and talk about Vault. I think Vault is, just like David alluded to, one of the hardest, security is one of the hardest layers to tackle. And we'll talk about why that is. I think for most folks who provision, let's say you're provisioning a system that needs access to a database server, it's almost guaranteed that the first thing that you need are credentials. And the second thing you need are a certificate. Those are usually the two things, and coincidentally, those are the two things that tend to cause the most problems when they get rotated. And so, but for the most part, if you're a client, you're going to request those things via ticket, and your database ops team will happily hand them over to you, and they're typically very long-lived. I think one of the jokes in the company is that typically when you issue credentials or a certificate, it gets issued for a term that's longer than the average tenure of your employees. That's because nobody wants to be here when it blows up in production, right? So having Vault in the middle there, being the service that you're requesting certificates from or credentials from, means that there's now an intermediary. The intermediary allows you to audit what's being requested. It allows you to rotate things because you have an intermediary. The call is the same every time, so it allows you to rotate very easily. The strange thing about Vault is that what most people don't realize is that Vault is actually, it's a security product, but it's really meant as an identity broker. Right? So you have a client, in this case it could be an AWS instance, that has an IAM credential, and you can exchange that IAM credential for any number of things. That could be a database server credential, that could be an SSH certificate, that could be maybe like if you're on AWS, maybe it could be like a GCP IAM credential, maybe it could be an on-prem Active Directory credential. There's all sorts of different things you could sort of exchange it with, which makes it a very powerful tool. It's just that the most common use cases for database credentials. And so because we have this, this sort of posture that we're doing identity exchange, your security team can basically set policies around who can do what IAM policies get access to what credentials, what policies or what credentials can be exchanged for other types of credentials. That's what the policy is all about declaring. Okay, so we talked about secrets management as being sort of a top use case. Other use cases that Vault sort of subsumes now are, one is data encryption, which I think is one that many of our customers struggle with, regardless if they're in public sector or not. For most companies, they're sort of issued this mandate that they're supposed to maintain security up to, I don't know, AES 256 or 512, take your pick. And the global risk and compliance team doesn't necessarily know how to achieve that level of encryption within an app. They just tell developers, go figure it out. And so developers, doing their due diligence will go to Stack Overflow, pick out the first search result, which is usually not what you want. I can guarantee you for a 256, it's not. And what they'll do is they'll put that in their application code and just assume it works. And what Vault allows you to do is take that extra work of the application developers that they're putting into their app, offloading it into a centralized service. That way, anytime data needs to be encrypted, you just make a request to Vault with your data. Vault will happily encrypt it for you and then ship it back. It's really handy for things like unstructured data, right? Blobs that have lying around like PDFs, things like that. For structured data, it can be a little harder, right, when you're working with databases. We do have support for NIST FF3, which what that means is called transformation. It allows you to take a piece of data, let's say like a United States Social Security code, which is 9 digits, and refactor it into another 9-digit number in the same format, just with different numbers. And because of the hash we use, we're allowed, we can decrypt it later. So the data that's actually in your database gets stored against schema, but it doesn't mean anything. So that's what I mean by transformation. So it's a very powerful tool that many customers I have internally for U.S. public sector, they're now looking at that as a way for sharing data across different health agencies. The last one is around advanced data protection. ADP is useful primarily for things like transparent disk encrypt, where the data has to be stored encrypted, especially through like a VMware farm. Vault can now back a VMware installation with, by providing things like certificates used for the encryption process. So that's really what Vault is used for. Some of our biggest users, I think Adobe is our largest one that I know of. They process something like 100 trillion transactions per year. If you can get above them, please let me know. I'd be curious to know about your workload. They literally hand it for every single transaction that goes on within the Adobe Creative Cloud, which is most of the marketing efforts that you speak to. That's where they all happen. So they have a very large transaction volume. We help them achieve that with Vault. So getting another layer up is the networking layer. I think the networking layer is one that it's interesting that it has the most commonality, right? It's just IP between all the public clouds. But for service mesh, what we talk about, there's the least commonality. I think that's the most fractured type of technology in the industry today. And so one of our chief goals with Consul is to help you create a unified network. Now, that doesn't mean necessarily it's going to replace like Direct Connect, for example, or Express Route. That's not the intent. The intent is to make it so that when applications are able to connect to each other, they're able to connect to each other, they find each other via DNS, and they connect to each other via policy, and they're doing so securely, implementing mutual TLS with a strong sense of identity for the service. That's what we mean by unified networking solution, and that's why it applies in multi-cloud environments. You could use it, on your own private network, could use it over the public internet, and all it uses TLS. So the Consul itself is, it's really just a registry. It's kind of like a phone book. When applications come up, they register to the registry with their name. In this instance, it's DB1, App Server 1, WS1. And so when DB1 registers, it'll get a name, db1.service.consul. It's a DNS name you can address via the Consul service. And there's a few different use cases here you can sort of parse out. So the first is that when customers start using Consul, I think one of the first things it starts replacing is a CMDB. If it doesn't replace it, what you can do is it'll give you a live snapshot of what's on your network and what's healthy. And you can just every night just dump in the results of the Consul registry into a CMDB. And so it's usually step one. Step two is starting to drive things like automation via Consul. So things like load balancers, for example, if DB1 comes up and DB2 also arrives, you can register both with a single load balancer, and that'll just be automatically registered to the load balancer, assuming that you have that configured correctly in your database. Probably a better example is your web service. As web service 1 brings up multiple instances of itself, it'll just show up with the load balancer configuration already in hand. So having that, having your load balancers automatically updated saves time in terms of how long does it take to file a ticket against the load balancer team and to see those results actually in production. One of the last cases that Consul is being useful for is around what we call service mesh. Service mesh is really about taking applications, giving them a strong sense of identity via an identity service like Vault, and managing policy. Now, it's not going to replace all your firewalls necessarily, although the goal is with things like microservices, it's extremely difficult to place firewalls between microservices. They scale rapidly. They're kind of dependent on each other's availability with low latency. And so having service mesh is kind of a requirement when you have a large sort of organically grown microservices environment. And so for our public sector customers who are investing in microservices deployment capabilities, they're looking very closely at service mesh and how this specifically can help them enable application teams to retain more autonomy over who can connect to them, as well as just doing so securely, forcing applications to connect to each other with things like TLS 1.3. Okay, so I sort of talked through many of this. The different use cases for our console. Network middleware automation is probably where most public sector organizations I talk to, that's where they kind of live today, is just trying to automate the updating of load balancers, or the next stage is really the updating of firewall rules. How can we provide them a consistent sort of approach that we do with both Vault and Terraform around that sort of network middleware layer, and creating providers for console to integrate with those things. So we have some integrations with things like Cisco ACI, Fortinet, F5. Those are all integrations that we've completed. And like I said, really the last is around, I'm sure everyone on the call is familiar with defense in depth, really talking about, implementing, a zero trust network where all traffic is encrypted and traffic is sort of organized by policy, and that policy is applied at the service layer. Okay, the next sort of last step, I think is Nomad. Nomad is the tool we use to provision and run applications. So it was really kind of built for those that are more familiar with Google, and sure everyone's heard of Google, but they have this approach internally called the Borg. And it's kind of a unique sort of way of approaching compute, scheduling applications across a very large fleet of instances that's sort of built for failure. As instances kind of come and go, the platform can reschedule things as things sort of live and die within the platform. And really, that's how Nomad was built. Nomad was built with those same principles in mind. It was actually built off of that paper. And so it inherits a lot of those kind of things that happen at scale. So some things that happen at scale is when you schedule containers. Nomad will figure out where the placement is based on policy. So you could say based on your security policy, it has to go in this region, not that region. Based on cost, it has to go in this provider, not that provider. Sort of rules like that. And that's what I mean by multi-cloud workload management. And sort of schedule one, it appears like one cluster, but really it's sort of this myriad of other Nomad clusters underneath. We call that federation, and that is one thing that Nomad really excels at. Another thing is the amount of containers it can schedule. I think for some customers like Roblox, for example, not necessarily applicable to public sector again, but I think just in terms of scale, I don't know if, I honestly don't know if Roblox is super popular in Australia. I know my kids here, I live on the eastern side of the United States, they would live on Roblox if I let them. It's just a very popular app here. I'm sure children are playing in Australia as well. And for that, they have millions of users connected to that every single day. And so they have to provision a container for every single user that gets connected. They use Roblox for all that. I think something that is more relevant to public sector is something like Cloudflare. Most folks are familiar with Cloudflare just on its ability to mitigate DDoS attempts as well as scaling websites. Every single cluster that Cloudflare runs around the world, every single one is backed by Nomad. And that's something they've been very public about. So in terms of scheduling containers, one of the best in the business. think one thing that it also does well is it's really designed around, it just schedules binaries. So whether that's a container, whether that's a Windows binary, a jar file, it doesn't really matter to Nomad. It just matters that it's something to run, and it knows it has a place it can run it, right? And then it'll figure out how to do that. That's the same sort of approach we have. I think it's the workflow-centric approach. The technology underneath is more of a detail of how the app gets run. And so whether it's container, jar file, Windows exe, doesn't matter to us. And so really, I mean, Nomad is much more popular than than I realized when I first joined. I joined about 1.5 years ago. I didn't realize that Cloudflare was running it. That was more of a recent thing, a recent revelation from them. And I think that what customers are looking for is a simplified experience where they can apply policy and give developers a really easy way to submit jobs to the platform. So it's really great for things like Spark workloads as well. Okay, so I talked about each of the 4 technologies. Each of them has kind of their own journey, we call it. Most customers, whether especially within public sector, I think they mainly start between Vault and/or Terraform. They look at those technologies. I think Terraform really defined infrastructure as code. Vault is now a #1 ranked technology for secrets management. So in terms of just where customers start, I think it's primarily there. It's very quickly the case, especially if you're in public sector, where you can't grant ATO unless they're able to meet policy requirements. And so very quickly with Terraform, you have to implement some method of governance and policy handling, which is why we provide Sentinel. And then, the last step is really providing, that users can write their own infrastructure as code, and they're sort of off and running. Something with Vault, it's really around, just figuring out the basics with it, just doing secrets management, getting that identity brokering working. And then you can start leveraging it for more complicated things, think encryption as a service, and creating certificates with it as well. Sort of the next step. For console, there's a clear sort of crawl, walk, run with, most people start with the registry, just having the DNS name available. The next step is automating based on the registry. The last step is implementing secure communication between different applications for these things. And sort of with the last step, as Nomad, most people look at it as a container orchestration engine. What they start looking at next is how do we start scheduling things like Windows apps on top of it as well. So making it a single approach to different platforms is something that's very important to us as well. It's important to a lot of our customers. There is sort of a maturity curve as far as when customers start adopting our technologies. And I think what is a consistent sort of theme is we've noticed that as the organizational complexity increases, their need for enterprise technologies increases. So we try to make it as easy as possible to be productive with a single tool. So you can run Terraform from the CLI. There's no constraints on it. Where we see that need for enterprise policy is as soon as you start having teams kind of using Terraform as a way to organize and deploy infrastructure as groups. So whether it's a team of users, your operations team, or whether you're allowing your development teams to consume it as well, that's where you start needing to add policy and governance onto it. So it's the same sort of consistent approach through all the technologies as well. I think that's it. So I'm not HashiCorp.com. I am B. Holden at HashiCorp.com. I guess with that, I'll hand it over to Brandon.
Good morning, everybody. It's still morning here. I'm based out of South Australia. It's currently 11:20 here. Okay, a little bit about me before I get started. This is a lovely picture. If you Google me, this one comes up a lot out of our CSIRO image library. I was very lucky early on in my career to be able to go out and start working with, out in the field with researchers. Not a lot of people get the opportunity to work out in the field. It's a very rewarding experience and a bit of a reality check to actually learn what it's like to be a researcher. So I've been in the IT industry now for about 20 years, starting out in the education sector as a systems administrator. Then gaining a position with CSIRO for 7 years supporting the land and water business unit, working as a systems/network/DB administrator /.NET web developer /solution architect. So we had to wear a lot of hats to support that business unit. And then moved to BA Systems to lead the web team there for 3 years before coming back to CSIRO Central IT Department, where I've been for the last 10 years, and more recently taking on the role of the Cloud Platforms team. Currently have 9 staff in my team, and we're assisting the delivery of the CloudRight body of work. I have a strong passion for providing researchers and engineers with solutions so they can provide impact. It's very addictive and very, very fulfilling. It's the main reason why I stay working at CSIRO. A little bit about CSIRO, for those that don't know. So CSIRO is a Commonwealth Scientific and Industrial Research Organisation. It's a bit of a mouthful, sometimes used in as a job interview question. So it's a good one to learn. So we're the leading government agency responsible for scientific research within inside of Australia. Currently have 5,000 full-time staff. I've got a list of the top 10 inventions there. A lot of people are quite surprised that CSIRO invented Wi-Fi. There's the top 10 there, and you can move on to csiro.au to have a look at a whole raft of things that we've invented there. So a lot of people are unaware that CSIRO not only does great science, but also contributes to the economy. The estimated present value of benefits from our work is around $4.5 billion per year. It's almost 3 times our total annual budget and more than 4 times the funding provided by the Australian government, with currently more than 1,800 patents. We're Australia's largest patent holder. This ever-increasing wealth of intellectual property is a vast source of commercial opportunity and has already resulted in more than 150 spin-off companies, with more to come. So I said before, we've got currently got 5,000 full-time staff spread across 10 business units that make up the Australian Centre for Disease Preparedness, Ag and Food, Health and Biosecurity, CSIRO Futures, Data 61, Energy, Land and Water, Manufacturing, Mineral Resources, and Oceans and Atmosphere. So before I get started about talking about the CloudRight project, I'll just give a little bit of context and background. So times are changing, capacity management, skill set requirements, and the time to delivery for research workloads is becoming increasingly challenging. CSIRO's got a significant investment in on-prem compute and HPC, along with access to national computational infrastructure. But research by its nature is very difficult to articulate the computing requirements up front. More often than not, when we're engaging with research projects to gather their requirements, the response that we were getting is, we just need storage and compute. How much we don't know. We just need to test something, or we just need to build a prototype. So if we look at a simple use case, which is still relevant today, but started way back early in my career, when a researcher used a desktop for solving problems, if they needed more compute, they simply purchased a bigger desktop. And then along came the boom of virtualization with VMware, and with a service desk request and 24-hour turnaround, researchers were provided with a virtual computer to run workloads on-prem, reducing the need for researchers to purchase a larger desktop. This all worked reasonably well within the walls of our on-prem networks. Then along came the boom of cloud. So AWS was launching, and this started to set the benchmark for how quickly our core IT department was expected to provision services. Shadow IT was gaining momentum as early adopters of cloud were providing faster access to compute. but early usage of cloud compute from projects demonstrated that they weren't thinking about security or the management layer around using a cloud platform. Traditionally, the management layer was taken care of by the central IT departments. Then our collaborators on projects started using cloud, and its usage started to be a requirement for early research engagements. So this list this list of dot points here could go on forever, but it's demonstrating here with ClickOps and shared responsibility. It didn't take long for simple demonstrators that were spun up on developer cloud accounts to turn into production workloads, or research to start running multiple projects out of a single cloud account. Many times with engaging with research projects that were using cloud, we found that if there was a team member within the research project that had the ability to spin up an EC2 instance, they were now the self-appointed tech lead for a project. Users were starting to spin up EC2s in the same way they would VMs on-prem, not understanding what the shared responsibility was in context of cloud, especially when it came to security. Researchers simply just wanted to get the job done. The problem now for the problem is how CSIRO provides the management layer and the guardrails required for cloud consumption, and provide simpler access to on-prem resources, but still provide a rapid or frictionless access to resources. So there's a quick quote on that page there. It's about 2 years ago. I met up with a researcher that we found was running a project workload off of their personal account, and in frustration, when we asked to take the cloud account off of them, his response to me was simply this: I don't want a cloud account, I just want to deploy my application somewhere quickly. So they were just looking for quicker access to resources. They didn't care where that was. They just wanted the capability for their projects. So over 2 years ago, we have a very proactive Chief Technology Officer who's the head of the scientific computing section of CSIRO by the name of Angus McCustra. He started putting together the CloudRight project to centralize the management of provisioning of cloud and improve access to internal resources. Phase one of this project is really focused on the management layer and the dot points above. So we really needed to start getting control over federated billing and chargeback. This gives us centralized billing aligned against projects for better forecasting, savings on central agreements, better understanding of compute and services being consumed by project, as well as an automated chargeback process for projects to remove the finance administration of cloud from the researchers. Centralized logging and monitoring. This is simply best practice across all cloud providers and on-prem, but more often than not, this is always an afterthought. The security. So defining the security requirements for cloud and, where possible, turning them into code is essential. This is a very important collaboration across all aspects of your business, including the vendor. More often than not, vendors are reaching out to researchers unbeknownst to our IT department, and it's important to get the major vendors on board early so that they understand your business requirements, especially around security, legal, privacy, ethics, and data classification. Authentication and authorization. Align with security in your directory services team. This one is one of the most important journeys you'll need to go on for all your teams to understand what secrets management is for both cloud and on-prem. Some simple examples that we've used in the past is how do you provide just-in-time access to cloud accounts, auto-create service principals within Azure, control access to compute instances without the instances being attached to your Active Directory, automate the storage and retrieval of application credentials, SSH key management, audit all access to your credentials, and most importantly, revoke access to credentials for a specific project in a central way. Common automation and configuration. So we really need to focus on putting more time back into the researchers' time. So we need to remove duplication and complexity, speed up the development time to production with approved templates, simplify solution building collaboration, provide a simpler method to skill up users to provision resources across multiple vendors, including on-prem. So with that in mind, very early on, we observed that Terraform and Vault were gaining momentum within the development communities as a more standardized approach to managing and provisioning infrastructure as code deployments, along with managing secrets. It was very clear we needed a managed Vault and Terraform implementation to overcome the complexity and duplication of deploying multiple vaults, along with the need to centralize the management of state files. So under the CloudWrite project, as part of our third-party tool set requirements, we implemented HashiCorp Vault and HashiCorp Terraform Enterprise. Early engagements with the 3 major cloud vendors, along with VMware, also confirmed our decisions to implement this stack as they're all adopting this capability. So if you only have to open up the Azure CLI console, you see Terraform is pre-installed, VMware moving to Terraform. So there's a strong adoption of the technology there. So just to give you an idea inside of CSIRO where we're currently at. So our team embarked on the journey of implementing Vault and Terraform. This is to give you an idea of the list of what's required to push an application to production for enterprise supported systems within CSIRO. This is for an enterprise application. So if we're now thinking about a research workload, this type of path to production is unrealistic for research workloads to go through the same amount of rigor, considering that most research workloads are short-lived. So we need a templated and automated approach to streamline this process for research and engineering workloads. So this is a diagram that we use to demonstrate what we've actually built internally. So this is for common automation and configuration, including the baseline best practice that we've co-developed with each cloud vendor and our security team that gets deployed to each and every one of our cloud accounts that get handed out to researchers. So we started with integrating our authentication for both the 3 cloud vendors and Terraform and Vault into Azure AD. We've got a custom-built cloud request form that gathers the required project information that's aligned with our tagging strategy, that generates a service desk request and kicks off the process to automate the provisioning of a cloud account with all the required baseline configuration linked to a Terraform org, a workspace, a Vault path, and their source control. Now, you've heard the speakers before. We really want to try and move away from a ticketed-based system. That'll be phase 2, phase 3, but at this stage, this fits in with the business processes that we have in place at the moment, and just kicks off. It's the first point of call for requesting a cloud account inside the organization. So with phase 1 of the CloudWrite project almost complete, we still have a lot of work to further improve automation and process, along with a long road to digital transformation for the entire business. So what have we learned so far? It isn't easy. As part of the CloudWrite project, we're not only building new capability, we're also servicing new cloud requests, continually remediating existing accounts, attempting to leverage internal team members across our IT section, which are extremely busy with business as usual, internal requests. Our internal processes and security requirements needed changing to adopt to a new cloud model. And all of government at the moment is currently hit with a current ASL cap. So we're actually restricted on the number of new full-time employees that we can hire. So we had a bit of a resourcing issue when initially trying to set up the team members for this project. So CSIRO is not a hosting provider, and we traditionally don't provide 24/7 support or application support, but this is going to need to change as we develop a new shared responsibility model. Deploying Terraform and Vault to cloud at enterprise scale was not a simple task. There was many phone calls to James and the technical teams. It needs very careful planning. The deployment needs to have security and directory services embedded into your projects. HashiCorp needs to be on board, and the cloud vendors need to be engaged as early as possible. A very well-defined tagging strategy aligned to your business is key, not only to assist with provisioning and deprovisioning, but to also drive the metrics to demonstrate the benefits of what you're doing. You also need to document the risk of your business of not putting in a managed cloud capability from a security and capability point of view. Engage with early adopters with inside of CSIRO for cloud was extremely important. We have a vast capability of developers and engineers within the organization, which are extremely intelligent people and provided fantastic feedback to help drive adoption. And invest in your people and provide training. CSIRO provides a huge amount of training and career opportunities. We just need to find the time to upskill more staff. So what's next? So currently we've laid the foundations, and now we need to start building modules for approved solutions to remove duplicated effort and complexity when technical teams are building solutions. This will increase security, improve the build time to production, allowing researchers to concentrate on getting back to just doing research. But we have to be realistic. ClickOps isn't going to be going away anytime soon for most researchers. There's a full digital transformation will take time, and the transformation needs to be adopted as far back as high schools and universities to ensure that we get the right skills coming through to support CSIRO moving forward. We need to concentrate on building internal communities to encourage more collaboration around the best usage patterns of cloud and the importance of secrets management. A lot of projects internally inside of our organisation still don't really have a clear understanding of what secrets management is and how Vault can assist them on their journey. And lastly, we need to create an organisation that attracts talent both at the researcher and the developer level, demonstrating the capability, modern tools, and the support that we have on offer. So measuring success, I spoke about before, setting up your monitoring and logging and your tagging so that you can actually quantify what you're doing is correct. And still to this day, there's many ways to measure success, but direct feedback from engineers out in the business is always a good reality check that you're on the right path. When you give developers and engineers the right tools to do the job, generally you never hear from them again. But when they do come back and give you feedback that you're seeing on the screen above, this is a demonstrator of an engineer that took over a project, had nothing to do with the initial build, had to re-engineer the entire project, had nothing to do with Terraform, and within 4 months, He's re-architected the entire system and created a module and now redeploying off of one click. So to me, this is a real success story in the eyes of what the Cloud Right project is doing at the moment. So with that, I'll go to any questions. Just noting that from my understanding at the moment, in talking with James, that CSIRO is the first government agency in Australia to provide managed cloud across the 3 major vendors, along with the implementation of Terraform and Vault. So I'm hoping now that this is going to provide a very good place for developers and engineers to come knocking on our door to look to gain employment. So, James, back to you.
Okay. Thank you. Thank you for that presentation, Brendan. Look, I hope everyone found that as enjoyable as I. It's great to hear how far CSIRO have come in your cloud adoption journey. So I'm just going to have a look now, everyone, for questions in the Q&A section. We've got time now. Now's the time to just drop any questions or comments in there. And we can review those and go through those now with the team on the call. I'll give you guys just a minute if you want to drop anything in there. Which is okay if you don't. Okay, there's one question from Nitin. It's for Brendan at CSIRO. Is CSIRO using any other HashiCorp products apart from Terraform?
Not. I'll say actually we've got teams using Packer, and I'm sure there's engineers with insider projects that would be using Console. So further phases of this project, we would be keen to start having a look at the support mechanisms around those products and how they would fit into phase 2 or 3 of our project. There's definitely a need, but at this stage we've been concentrating on the management layer.
Okay, there's a similar question in line from Steve Cross. G'day, Steve. Are CSIRO planning to implement Console?
We're not planning it yet. It's definitely something that we'd have a look. I mean, there's obviously a requirement for that technology. Whether we use Console, not quite sure at this stage, but we'd definitely be having a look at it.
Thanks, Brendan. All right. That looks like it from questions dropping in at the moment, so that's okay. I think that brings us to an end today, everyone. I hope you found that useful. As I mentioned earlier, the session has been recorded, so you will receive an email with a link to the recording. If you liked what you heard today, you want to learn more about HashiCorp solutions, I encourage you to check out our Learn pages, learn.hashicorp.com. And then, look, just again, a final thank you for joining us today, but a big thank you to our presenters. Thank you, David Carlis, Brent Holden, and thank you very much, Brendan Speet from the CSIRO. And that's it, guys. That's a wrap. Enjoy the rest of your day, and bye for now.